In this video, we're going to do a quick review of some of the problems that you have on the review problems, and then I'm going to review one of the homework problems that may be a little difficult. And so let's go ahead and get started. Hopefully this will help you prepare for your exam 3. All right, I want to look at number 2 on the review problems for exam 3 sheet. It says find the critical points and inflection points of the function f of x equals 4x times e to the 3x. Also identify each critical point as a local maximum, local minimum, or neither. All right, and so if we look at this example here, remember if we want to find the critical points, we have to look at the first derivative of the function. So for me to find my critical points, I'm abbreviating that with CP, I'm going to find my first derivative. If I look at that function, that's an F by the way, not a P. But this is a product rule, right? Because I have two functions of x multiplied by each other, right? So this is kind of a review of section 3.4 as well. All right, and so if I want to find a derivative, I do the derivative of the first function, which is 4, times the derivative of the second function, the derivative of the first function, which is 4, times the second function, plus the first function times the derivative of the second function, which is e to the 3x. Since that's not just an x in that exponent, I have to use the chain rule multiplied by the derivative of 3x, which is 3. I set my derivative equal to 0 in order to help me find my critical point. So I'm going to solve this equation here, 4e to the 3x, plus when I combine this 4 and this 3 together, I get 12x times e to the 3x equals 0. For me to solve this equation here, I am going to factor. I'm going to factor out a 4e to the 3x because both of those terms have that in them. When I factor that, I'm going to get a 1 from that first term. 4 goes into 12 3 times. I have that x, and I factored out this e to the 3x, so I get 1 plus 3x, and all that equals 0. Remember, the goal of factoring, or the purpose of factoring, was to see that I have a product of two numbers and their product equals 0. That means if I want to find a solution to this equation, at least one of these have to equal 0. So I'm going to set both of them equal to 0 because we want all the solutions. 4e to the 3x equal to 0, or 1 plus 3x equal to 0. Equals 0. At least one of them has to. I'm going to solve these equations for x, divide both sides by 4. I get e to the 3x equals 0. And what I would do now is I would take the natural log of both sides because I don't want x to be in that exponent. But if you notice, all right, here the natural log and e kind of cancel, but this right here is undefined. ln of 0, if you put in your calculator, you're going to get an error. It's going to domain area, error. 0 is not in the domain, right? So there is no solution to this equation here, e to the 3x equals 0 or 4e to the 3x equals 0. So I'm not going to get a part of my solution there. But I can get a solution here. Subtract 1 from both sides, and then divide both sides by 3. I get x equals negative 1/3, right? So this is my only critical point. It is a critical point. If I do my f prime line, I plug my critical point on there, and I just want to try some numbers to see if I get a max or a min, right? I'm going to plug these numbers that I'm going to use into this expression here. All right, you can go back to the original and see, plug in a number and see if you get positive or negative, and it'll give you the same outcome, right? This is more simplified. All right, I'm going to pick a number like negative 1. That's on that interval, right? If I plug it in this first term, notice anytime I plug anything in to e to a power, it's going to be positive, right? And so all I have to really do is worry about this. So if I plug in negative 1 here, I'm going to get 1 minus 3, which is negative. And so I know my derivative is negative from negative infinity to negative 3. And I'm going to pick a number like 0 here. Again, this part right here, 4e to the 3x, it's always going to be positive no matter what number you plug in for x. So all I really have to do is look at this one here, plug in 0, I'm going to get 1, and that's positive. So my function is decreasing on that interval and is increasing on that interval. When that happens, I'm going to have a minimum. So I have a local min at x equals negative 1/3. Okay. Part B asks us to find the not part B, but I want to find the inflection points. All right, find the inflection point. I can use the second derivative. I'm going to call this IP. Now, I found that my first derivative was this thing right here. In your notes, I did the derivative, I think, well, I didn't show you the solutions. I just gave you the answers, right? What I'm going to do is I'm going to use this right here, this 4e to the 3x. This is f prime as well. And I'm going to do the derivative of this thing to give me the inflection point, all right? This is also a product rule. So I'm going to do the derivative of the first function, which is that 4 stays there. The derivative of e is e, so I'm going to have e to the 3x. Got to use the chain rule because that's not just an an x, that's a 3x. So I got to multiply it by the derivative of 3x, which is 3. So that's the derivative of the first function times the second function. So I'm just going to write down that. Plus the first function, which is 4e to the 3x, times the derivative of the second function. Well, the derivative of 1 is 0 here, and the derivative of 3x is 3. And I need to set that equal to 0 and so I can find my inflection point. So I'm going to simplify this part, right? I have 4 times 3, which is 12. I still have that e to the 3x. I have that 1 plus 3x there. And then I have this 4 times 3, which is 12. E to the 3x. And I can factor in order for me to solve for 0, right? If I factor out a 12e to the 3x, I'm going to be left with, and I could use a parentheses here, that's just a bracket, it's like a parenthesis, it's nothing special, okay? This first term, I'm left with e to the 1 plus 3x when I factor out this 12e to the 3x. And then the second term, I'm just left with 1. So this boils down to e to the 3x times 2 plus 3x. Because if I add this one with that one, I get 2, and I still have that 3x there. Two things that multiply together to give you 0. One of them has to be 0. We set them both equal to 0 to give out all of our possible solutions to the equation. This one, again, just like over here, this one didn't have a solution. This one right here does not have a solution, right? So my only solution is going to come from 2 plus 3x equals 0. I subtract 2 from both sides, divide both sides by 3. I get x equals negative 2/3. This is a candidate for an inflection point. Be careful here when we talk about inflection points. You have to go through this process here to see if this inflection point is indeed, or this number, this value of x is indeed an inflection point. It has to change signs on both sides, right, of that value. So I put negative 2/3 in for x on my number line, my f double prime line. I'm going to go here to test to see if I get a positive or a negative value. I'm going to try a number like -1 to represent that interval. This first part here is going to be positive always, so I'm going to have a positive. The second part, if I plug in -1 for x, I'm going to get 2 minus 3, which is a -1, so this is negative. That means that my function is concave down. My function is concave down when my second derivative is negative. And then I'll plug a number like 0, because that's to the right of negative 2/3, into this second derivative. This first part is going to be positive, and the second part is also going to be positive, so I get positive. So since it changes signs, I don't really care whether it's negative or positive, and then or positive to negative. As long as it changes signs at this point, I can say that x equals negative 2/3 is in, I'm going to abbreviate inflection point with IP. All right, there's some more problems, but these videos have to be really short, so I'll see you on the next video.